Could humanity be the only civilization in the universe? If extraterrestrial civilizations truly exist in the universe, why, as of today, in 2025, have we still not discovered them? Is it because human technology is not advanced enough? Or is the universe designed solely for us? To unravel these mysteries, scientists have proposed 6 different theoretical explanations. The first is the Fermi Paradox. The Fermi Paradox represents an idea proposed by physicist Enrico Fermi in 1950. Fermi hypothesized the existence of extraterrestrial life, or intelligence. Such advanced technological civilizations should be capable of surviving for millions of years. During this time, through interstellar and intergalactic travel, they should be able to colonize entire galaxies. Fermi went even further, assuming this has already happened. However, searches for extraterrestrial life have so far been unsuccessful, which creates a contradiction for scientists. This led him to question his observations and assumptions, forming the Fermi Paradox. Because the universe is extremely old and contains numerous stars, life should exist beyond Earth unless the origin of life on Earth is an unusual process. This is also known as the rare Earth hypothesis, which posits that Earth does not hold a unique position in the solar system. And other technological civilizations exist in the Milky Way. Although the Milky Way spans about 100,000 light-years, traveling across such distances at sublight speeds would take up to 10 million years. However, the Milky Way is about 10 billion years old. If civilizations capable of interstellar colonization exist, the entire galaxy could have been colonized within a few million years, a duration far shorter than the galaxy's age. Thus, extraterrestrial life should exist somewhere near Earth. Yet no evidence of it has been found. In short, the Fermi Paradox asks, if extraterrestrials do exist, why aren't they here? The Drake equation is closely related to the Fermi Paradox. So far, most of its parameters remain unknown, so it does not significantly help resolve the paradox. The Drake equation pertains only to our galaxy, the Milky Way, which is a barred spiral galaxy type that constitutes about 2/3 of galaxies in the universe. Given that the observable universe contains roughly 100 billion galaxies similar to the Milky Way, the final value of the Drake equation must be scaled by a factor relative to the entire universe. Although this significantly increases the total number of possible civilizations, our limited understanding of other galaxies makes such calculations highly imprecise. Moreover, the Drake equation not only concerns the theoretical number of civilizations, but also the possibility of establishing contact with them. The nearest galaxy, the Andromeda Nebula, is 2.5 million light-years away, making it practically unreachable for contact. Their galaxies are even farther. One hypothesis suggests that we are truly alone. This argument claims that multicellular life in space is extremely rare, because Earth-like planets are themselves scarce. The development of life on Earth resulted from numerous improbable coincidences, making the existence of other Earth-like planets equally unlikely. These coincidences include the presence of the Moon and Earth's position in the solar system, which ensure temperatures suitable for life. In this interpretation, the parameters of the Drake equation are set such that humanity is the only civilization in our galaxy. Resolving the Fermi Paradox by negating one of its fundamental assumptions, many scientists find this hypothesis convincing. However, some argue that Earth-like planets do exist, supported by the increasing discovery of exoplanets. The premise of the Fermi Paradox assumes the existence of civilizations capable of interstellar colonization. However, in principle, this may be unfeasible because even if technological civilizations exist, the vast distances prevent them from influencing one another. For example, even traveling at the speed of light, it would take several years to reach the nearest star, Proxima Centauri, and current knowledge suggests the speed of light cannot be surpassed. This raises several questions. Can a civilization truly reach other star systems? Is doing so beneficial for that civilization? Additionally, to what extent is the time delay in communication between groups in different star systems acceptable to maintain the necessary cohesion for a civilization? Stephen Hawking believed that life beyond Earth is possible, and that humanoid intelligent life could exist. However, he also believed that such intelligence would eventually reach a limit, become unstable, and inadvertently lead to self-destruction. Genetic engineering, viruses, nuclear war, or an uncontrollable greenhouse effect could trigger such extinction. The Berserker hypothesis, named after Fred Saberhagen's Berserker saga, suggests that extraterrestrials launch artificial probes into space that destroy other civilizations. These probes deliberately eliminate other life forms to preemptively neutralize potential enemies, allowing their creators to spread through space unimpeded. The Dark Forest hypothesis, named after Lou Sixon's trilogy The Dark Forest, is thematically similar. It posits that extraterrestrial civilizations exist, but remain discreet and conceal their activities to avoid detection by potential enemies, reducing the risk of being preyed upon. This is akin to biological camouflage. According to this theory, the universe is a dark forest filled with predators, while competing to perfect their concealment. An astrophysical explanation points to gamma ray bursts, considered the most energetic phenomena in the universe. These bursts could cause mass extinction on planets within their radiation cones, even light years away. It is suggested that during the first 5 billion years of the universe, intense gamma ray activity made the evolution of complex life forms in galaxies impossible. Astrophysicist J. Richard Gott does not believe the argument for galactic colonization holds. He argues that if it were true, all life would belong to such a super civilization if other civilizations exist. It is unlikely that we would have emerged on a relatively young and small planet like Earth that has not yet been colonized. Great Filter concept synthesizes some of these ideas. It suggests that there exists a filter, a barrier, or challenge that civilizations must overcome at a certain stage of development. One possibility is that advanced intelligence is extremely rare in evolution, and humanity is so far the only life form to have overcome this filter. Alternatively, as civilizations expand, certain developments inevitably lead to their extinction at some point. According to this view, other civilizations failed to overcome the filter, and humanity must still do so. Philosophical reflections on extraterrestrial life date back to ancient times. In Plutarch's work on the face of the moon, ideas about non-Earth life forms can be found. However, these texts are largely tied to mythology and cannot be considered attempts to construct rational theories about extraterrestrial life. Another issue in astrobiology is the lack of a unified definition of life. Numerous attempts to define life have been made, but none are complete or satisfactory. This leads to the conclusion that there may be no fixed boundary between life and non-life. Even if life similar to Earth's exists, it remains unclear whether it originated on Earth and spread to space, or arose independently elsewhere.